The ICEVI, the Nippon Foundation Mathematics Package for Teachers video series, Abacus as a Mathematical Tool. Title of the video, Finding out the square root of a perfect square, example 4225. Set the number 4225. That is, you set the number by leaving 3 columns to its right. Now, this number can be grouped as 42 and 25. Take the first group, that is 42. What is the highest perfect square in 42? That is 36. And set the square root of 36 in the left of 4225. That is, set 6 to the left of 4. Now, multiply 6 with 6, that is 36, and this should be subtracted from 42, which is leaving 6. Now, you are left with 625. Now, double the number 6, which is the first digit of the square root, and the value is 12, and set the value 12 in the extreme left of the abacus. In the previous example, doubling the first digit of the square root also gave a single digit number, but now we are getting a double digit number, and let us see how to handle this in the calculation. Now, take the number 12 and 625, that is to be divided. Take the first digits. How many ones of 12 are in 6? Though it is 6, reduce 1, and therefore it will be 5. So here we have applied the assumed quotient concept. Set 5 to the right side of the first digit of the square root and make it 65. Set 5 to the right of 12 and make it 125. Multiply 5 with 125 and subtract it from 625. If required, 5 multiplied by 125 can also be treated as a separate operation using abacus. Now, 5 multiplied by 125 is 625. That should be subtracted from the abacus, and you will not get any remainder. Therefore, the assumed quotient of 5 is the actual quotient. That is, the square root of 4225 is 65. That is, the square root of 4225 is 65. We have to note that in the second level calculation, when we dealt with 625 and 12, we applied the division guidelines. Let us reset the problem. In the second stage, we had 625. Here, we treat 625 as the dividend and 12 as the divisor. Like a regular division problem, we considered the highest digits of the dividend and the divisor and adopted the guidelines for setting the quotient and also in guessing the assumed quotient. We considered 6 and 1 for getting the assumed quotient. If the child is comfortable, we can take the first 2 digits. That means consider 62 of the dividend and 12 of the divisor. There are 5 12s in 62. Whenever the multiplied value is closer to the digits of the dividend, you can consider the actual quotient and need not reduce 1 to work with the assumed quotient. In that case, you can straight away set 5 as the second digit of the square root, set 5 to the right side of 12 and subtract 625 from the dividend, which is giving 0. Therefore, there are a number of options available for carrying out the different stages of calculations in getting the square root. We keep insisting from the beginning that the knowledge of multiplication tables will help to a great deal in handling problems in multiplication and division. Whether it is fraction multiplication and division or decimal multiplication and division, we can convert them to the normal multiplication and division procedures, and therefore calculation will be much easier when the child is conversant with the multiplication tables. Though it should not be considered mandatory, that may sometimes be used as an excuse for avoiding abacus, knowledge in multiplication tables should be treated desirable.